So good afternoon, everyone. In today's session, we will start with the homework that I gave in the last class. That was a previous JE question that got repeated in many examinations later on. Okay, what was the question? The question was this: express energy in terms of force, acceleration, and time. Am I correct? Someone says, please, if it is correct. Yes. Express energy in terms of force, acceleration, and time. Okay, that was a question that I gave in the last class. This is a previous question, the question that got repeated. Okay, so how do we do this? You have to write the quantity which is to be expressed on the left side. Okay, so what is the quantity? I need to express energy. And what should be written on the right side? You know, the quantities in terms of which this should be expressed. So I should write f raised to some power, a raised to some other power, t raised to a third power. So how do we write this? Whenever you are asked such a question, you should write. No, this is an extra question. This was given as a homework in the last class. This is not there in the paper. Okay, so express energy in terms of force, acceleration, and time. That was a question. You need to express energy. Usually energy is written how? Energy is written ml square t raised to -2. But there is a condition. Who must be the fundamental quantities? M, L, T. If MLT are the fundamental quantities, like we have now, if M, L, and T are the fundamental quantities, we can express energy as M, L square t raised to -2. But this is somewhere else, where the fundamental quantities are no more MLT. You are in a new planet or something. Okay, or you are in a new universe, wherever it is. Anyway, you know, the fundamental quantities are not MLT anymore. They are what? They are force, acceleration, and time. So in simple terms, I need to express energy in terms of force, acceleration, and time. So what should I do first? I should write the quantity to be expressed, that is energy, on the left side. And on the right side, I should write the terms in terms of which the energy is to be expressed. Force is there, acceleration is there, T is there, and you should give some powers for them as well. Then you can apply dimensions, whatever we've been doing. Energy is given by what? ml square t raised to -2 is equal to, force is given by what? ml t raised to -2 raised to x. Acceleration, remember this is not area, it is acceleration. Acceleration is lt raised to -2 raised to y. And this is time. Time is t raised to z. Okay, so I'm just substituting the dimensions here. I'm just giving the dimensions here. Now I can compare. What do I get if I compare? What is the power of m on the left side? The power of m is m raised to 1 here, right? So it is 1. 1 is equal to. What is the power on the right side? M raised to x is there. No other m. So x is equal to 1. I got my first number. Now let us compare L's. What do we get if we compare L? L is, the power of L is 2 is equal to, power of L is what? L raised to x is there, L raised to y is there. L raised to x into L raised to y is L raised to x plus y. That is our second equation. So right there you can find out y values. So 2 is equal to x is 1 plus y, or y is 2 minus 1, y is 1. So I got x, I got y. Now I can find out z. How do you find z? The power of t is -2. The power of t is -2. The power of t is -2 and x. Look at that, x raised to m. The whole raised to n is x raised to m into n. So t raised to -2, the whole raised to x. -2x. Here it is -2y. Here it is plus z. So let us put the values here. -2 is equal to -2 into x is 1 -2, y is 1 plus z. So I keep this z along on the right hand side. I have -2 here, -2. This is actually 2. -2 comes to left side to become +2. And this -2 also comes to left side to become +2. So -2 plus 2 cut, z is equal to 2. Now finally I can write my expression. Energy is to be expressed right? F raised to x. F raised to x is what? X is 1. A raised to y. Y is what? 1. T raised to z. Z is 2. So I can write it this way. F into A into T square. Did you understand? This was the homework that I gave in the last class. So let us start with question number 15. Okay, question number 15. Previous question. The frequency of vibration. Frequency. You know what frequency is? We have learned one question involving frequency as well, right? Frequency of vibration of a mass suspended from a spring of spring constant is given by the relation F is equal to Cm raised to x k raised to y, where C is a dimensionless quantity. The value of x and y are. Read it again. Frequency of vibration. What is frequency of vibration? You don't have to know actually, but I'm telling you. I have a spring and a mass attached to it. Look at this. This is a mass attached to a spring. You are just pulling it and releasing it. What will happen? It will execute up and down motion. Am I correct? Am I correct? Say something, please. We have a spring to the free end of which you are attaching a mass. This is a mass. This is a mass attached to the free end. And then you're just pulling it and releasing it. What happens to the mass? It is moving up and down. So it has a frequency of vibration. Frequency means number of vibrations in 1 second. If it completes 10 vibrations, this is one vibration. Second vibration, third vibration, fourth vibration. So if it executes 5 vibrations in 1 second, we say that the frequency is 5 hertz. Okay. So frequency is nothing but the number of vibrations completed in 1 second. So what do they say here? They say that frequency is given by Cm raised to x k raised to y. They have directly given the equation. They are asking you to find out x and y. So easy. Usually this constant is taken as k. Usually this constant is taken as k, but this time they have given c because k has already been taken there. Spring constant is k. Okay, spring constant is k. Last class, I don't remember if I told you or not. Dimension of spring constant. Did I tell you? If I didn't, you can write it down here. Dimension of spring constant is m t raised to minus 2. Actually, you don't have to learn it by heart because by the time you write the entrance examination, you will have learned this thoroughly. Okay. So mt raised to minus 2. This is question number 15. Question number 15, 1-5. Okay, question number 1-5. Previous question. F is equal to Cm raised to x, k raised to y. Cm raised to x, k raised to y. So you can apply dimensions on either side. Dimension of f. What is dimension of f? T raised to minus 1. Why is it t raised to minus 1? Because frequency is reciprocal of time period. Do you remember? Reciprocal of time period is called frequency. 1 by t. So dimension of frequency is t raised to minus 1. I said this once in class. I'm repeating. Frequency is nothing but the reciprocal of time period. Reciprocal of time period. The reciprocal of time period is called frequency. And if you put the dimensions over here, this is t and t is taken to numerator, it is t raised to minus 1. So dimensions of frequency are simply t. So I can put it here. This is t raised to minus 1. Sorry, t raised to minus 1 is equal to c is a dimensionless number. C does not have any dimensions. Then m's dimensions are m raised to x. Spring constant, I wrote it there. Mt raised to minus 2 raised to y. Mt raised to minus 2 raised to y. So let us compare m's now. What do we get if you compare m's on either side? There is no m on the left side. I don't see anything. Do you see? No, nothing. So it is 0 is equal to, what is m here? M's power is x. So that is x. X is equal to 0. Oh, I'm not done yet. Sorry. This is x and I have m raised to y here. I forgot. M raised to x is there. M raised to y is there. M raised to x is there. M raised to y is there. So m raised to x into m raised to y is m raised to x plus y. So that is my first equation. Did you understand? So we have 0 is equal to x plus y. And should I compare L's here? Should I compare L's here? No, no need to compare L because there is no L on either side. So I can just compare T's now. Yes, Veda. Thank you. T's comparison. Tell me what? T is minus 1 here. Look at the power of T. It is minus 1. T's power is minus 2 and y. Minus 2 and y. X raised to m the whole raised to n is x raised to m into n. So T raised to minus 2 the whole raised to y is minus 2 into y. So I can cut minus and minus. This is y is equal to 1 by 2. I got y. I can put it in here. 0 is equal to x plus y. 0 is equal to x plus 1 by 2, x is equal to, take it over to left hand side, minus 1 by 2. So x is 1 by 2, x is minus 1 by 2, y is 1 by 2. Answer is option D. X is minus 1 by 2, y is 1 by 2. Did you understand? Minus 1 by 2, 1 by 2. Option D. Moving on to the next question, 17th one. 15th one we did now. 16th we'll come back and do. 16th also we can do now. 16, 17 in sequence, okay? The velocity, 16th question. The velocity of a freely falling body changes as g raised to p h raised to q. So velocity of a freely falling body changes as g raised to p h raised to q. Okay, so velocity of a freely falling body. What is meant by freely falling body? A body that is falling down is called freely falling body. A body that is falling under acceleration due to gravity is known as freely falling body. So a body that is falling under acceleration due to gravity, that is known as freely falling body. And its velocity changes. Changes means proportional to, depends on velocity changes as g raised to p h raised to q. Then the values of p and q are. Try it yourself. I'm doing it here. If you are not able to do, you can see the board. V is equal to, first of all, you have to put a constant into g raised to p h raised to q. Then put dimensions on either side. What are the dimensions of V? LT raised to minus 1. K's dimension is not to be written. G is acceleration due to gravity. LT raised to minus 2 raised to P. H is height. That is L raised to Q. Repeating. I'm just putting a constant here to remove the proportionality. So that looks like V is equal to K into G raised to Q. G raised to P, H raised to Q. Then I put dimensions on either side. On both sides, this is LT raised to minus 1 on the left side. On the right side, it is LT raised to minus 2. LT raised to minus 2 raised to P into H is height. Height is L raised to Q. Then I can apply M's. M not to be written because there is no M on both sides. Okay. Then either side. Then what? Let us compare L's now. L's power. What is the power of L? The power of L here is 1. 1 is equal to, the power of L here is P, L here is Q. L raised to P into L raised to Q is L raised to P plus Q. Yes, this is P plus Q. L raised to P into L raised to Q is L raised to P plus Q, equation number 1. Let us compare T's now. The power of T is minus 1 is equal to, what is the power of T? Minus 2 and P, minus 2P. There is no T here. Minus and minus are cut. P will be what? 1 by 2. This is P. Having obtained the value of P, I should move on to find the value of Q. How do I find? I can put it in this equation. 1 is equal to P plus Q. 1 is equal to half plus Q. Or Q is equal to 1 minus 1 by 2. Or Q is equal to 1 by 2. So P is equal to 1 by 2. Q is equal to 1 by 2. Yes, that's right. Answer is option B. Did you understand? So move on to the next question. Question number, I'll tell you. Question number 17. Read the question. If energy is to be expressed, if energy, velocity and force to be taken as fundamental quantities, then what are dimensions of mass? Read it again. If energy, question number 17, 17. If energy E, velocity V, and force F are taken as fundamental quantities. See this? Our usual fundamental quantities are M, L, T. In that case, mass is represented as M. But here the fundamental quantities are energy, velocity, and force. Say that again. Energy, velocity, and force. And you have to write the dimensions of mass. Or in other words, mass is to be expressed in terms of energy, force, velocity. So how do you write? Mass is to be expressed. Mass is to be expressed in terms of what? Mass is to be expressed in terms of energy, velocity, and force. Did you understand the question? What are they asking here? You know, if the fundamental quantities are not mass, length, time, MLT, not MLT anymore. Instead, they are energy, velocity, and force. Then they are asking you to write the dimensions of mass. So in other words, they are asking you to express mass in terms of energy, velocity, and force. Let us do this. Right. So what are the dimensions of mass? It is M. Energy dimension, I told you, you have to learn by heart. ml square t raised to minus 2 raised to x. Velocity is dimension lt raised to minus 1 raised to y. Then force is dimension m l t raised to minus 2 raised to z. Okay, so there are three quantities to be written here. Now tell me, how about comparing m's now? Comparing m's now, this is m. M's power is 1. What is the power of m here? M's power is 1 is equal to, here it is m raised to x, that is x. M raised to x. Then m raised to z. So x plus z, that is equation number 1. Let us compare L's now. Is there an L on the left side? No, 0. It's equal to, what is the power of L here? Look at that. This is 2x. 2x. Then plus y. Then plus z. See this? I'm just comparing L's now. There is no L on the left side. So L is gone. Here L raised to 2x. So 2x. L raised to y. Then L to the power of z. Then let us compare T's now. T's dimensions. What are the dimensions of T? 0 is equal to minus 2 and x. Minus 2x. Minus 1 and y. Minus y. Minus 2 and z. Minus 2z. Those are equations 2 and 3. What do we do now? Equations 2 and 3 can be directly added. What do we get if you add them up? Equations 2 and 3 are added. 0 plus 0, 0. Plus 2x minus 2x cut. And then y and y are getting cancelled out. Minus 2z plus z. Minus z. So z is equal to 0. I got z. Minus z is equal to 0 means z is equal to 0. Now I can put it here to get x. 1 is equal to x plus z. Okay, so 1 is equal to x plus z is 0. So x is equal to 1. That is our second term. Then let us move to find y. How do you get y? I can put in either of these equations. I'm going to put it over here. 0 is equal to 2 into x. 2 into x. X is 1. 2 into 1 plus y plus z is 0. So that is what? This is 2 into 1 is 2. That is taken to left side. Minus 2 is equal to y. So I got x, I got y, I got z. I can put it over here. So mass is represented how? E raised to x. See this, e raised to x. X is 1. V raised to y. Y is 0. Y is 0. Oh, y is not 0. Y is minus 2. Minus 2. And then force raised to z. Z is 0. F raised to 0 is 1. Any number raised to 0 is 1. So what do we get? E by v square will be the final answer. E by v square. Did you understand this? The answer is EV raised to minus 2. EV raised to minus 2 or option B. EV raised to minus 2. EV raised to minus 2. Option B is correct. Did you understand? I'm asking everyone, tell me please. So actually we have seen one application of dimension analysis now. Now next is something related to dimensions again. Principle of homogeneity. You must have seen this in school classes, but there are different questions here in entrance examination. Okay, right? I'll tell you what is principle of homogeneity. I'll tell you. I'll just state the principle. If m raised to x, l raised to y, t raised to z is equal to m raised to a, l raised to b, t raised to c. If this is to be true, then x must be equal to a, y must be equal to b, and z must be equal to c. That is what the principle states. Principle of homogeneity. So according to principle of homogeneity, read it please. If m raised to x, you can write this down. You have to make a small note, okay? M raised to x. This is called principle of homogeneity. This is coming in school examinations also, okay? Principle of homogeneity. But there will be advanced level questions here. You know, we'll do the tougher questions here in entrance classes, okay? Principle of homogeneity. According to principle of homogeneity, if m raised to x, l raised to y, t raised to z is equal to m raised to a, l raised to b, t raised to c. If this is to be true, then the powers, exponents of m should be identical. You know, m raised to x, m raised to a. The power of m is x, the power of m is a. X should be equal to a. Then Power of EL is Y, power of L is B. Y should be equal to B. Power of T is Z, power of T is C. They must be equal. X is equal to A, Y is equal to B, and Z is equal to C. This is what principle of homogeneity says. And how do you state it? This is a statement, actual statement. And how do you use this? You know, I'll tell you a simple statement here. Look at this. I have a statement here. A plus B minus C is equal to D. This is a simple mathematical statement. It's got what all things? There is a plus sign, there is a minus sign, there is an equality sign. Plus sign, minus sign, equality sign. All these signs, if you compare plus sign, minus sign, equality sign, if you take a plus sign, minus sign, equality sign, on both sides of the sign, dimensions must be same. Dimensions must be same, or units must be same. Okay. For example, you know, does it make sense to write 8 meter plus 3 kilogram minus 3 seconds is equal to or 2 seconds is equal to 9 meter per second? Is this correct? 8 meters plus 3 kilogram minus 2 seconds is equal to 9 meter per second. Is that correct? No. If this is to be correct, on both sides of plus sign, the unit should be same. It should be meter or kilogram. And then on both sides of minus sign, unit should be same. On both sides of equality sign, unit should be same. Now see this. This makes sense, right? 8 meter plus 3 meters is 11 meters. 11 meters minus 2 meters is 9 meters. Understood? So this is exactly what principle of homogeneity says. Whenever we have a plus sign, addition, subtraction, or equality symbol, plus symbol, minus symbol, or equality symbol, check either side of the symbol. Both the sides, the immediate terms should have identical signs. This doesn't apply to division and multiplication. Division, multiplication, you know, you are not supposed to use this rule. This is to be applied only in the case of addition and subtraction. Addition, subtraction, and equality symbol. So this is the actual statement of principle of homogeneity. I'm reading that again. M raised to X, L raised to Y, T raised to Z is equal to M raised to A, L raised to B, T raised to C. If this statement is to be true, then X should be equal to A, Y should be equal to B, and Z should be equal to C. And in layman's language, in common man's language, we better state this way: A plus B minus C is equal to D is a mathematical statement which has a plus sign, minus sign, and equality sign. And on both sides of the sign, dimensions must be the same. This is what principle of homogeneity says. Did you understand? Okay, so take the paper again. We will start with question number 1. Given that, read question number 1. Given that force is given by F is equal to Pt raised to minus 1, Pt raised to minus 1 plus Qt. Pt raised to minus 1 plus Qt. We have an equation here, Pt raised to minus 1 plus Qt, where T is the time. The unit of P is same as that of the unit of P. You got to find the unit of P. How do we find this? Pt raised to minus 1. We have been given an equation. Pt raised to minus 1 is equal to Qt. How do you apply principle of homogeneity? Look for equality sign. This is an equality sign, right? So both sides should have same dimensions. So dimension of force must be equal to dimension of P into dimension of T raised to minus 1. And then this is what? Dimension of P is then what? Is equal to dimension of force into dimension of T. Why? Why? This was actually T raised to minus 1. When T raised to minus 1 is taken to left side, it becomes T raised to plus 1. Am I correct? Oh, tell me what? This T raised to minus 1 is actually 1 by T. 1 by T. 1 by T. T goes to this side. It is F into T. Correct? F into T. Correct? So let us put the dimensions. Dimension of force is equal to what? Dimension of force. Force is mLT raised to minus 2 into time is T. Then that is mLT raised to minus 1. It is dimension of P. Look at that. Dimension of P. Dimension of P. It is T raised to minus 2 and T. This is T raised to 1, right? So it is T raised to minus 1. mLT raised to minus 1. What is this? This is actually, this m is mass and LT raised to minus 1 is velocity. Velocity. mv is called momentum, linear momentum. Linear momentum. So this P is actually same as what? Linear momentum. Is that there in the options? Unit of linear momentum. Unit of linear momentum. Ah, yes, option D is correct. Option D is correct. I'll do that one more time. They have given you an equation here. F is equal to Pt raised to -1 plus Qt. And they're asking you to find the unit of P. Unit of P is same as dimension of P. They are asking you to check the dimension of P. How do you check? You can use principle of homogeneity. Look at the equality symbol. This equality symbol. Left of equality symbol is force. Right of equality symbol is Pt raised to -1. Okay. So if I keep P alone on the left side, right side, T raised to -1 goes to the left side. It is T raised to +1. Okay. So dimension of P is equal to dimension of force into dimension of T. What are dimensions of force? M, L, T raised to -2. And what is T? Time is T is equal to P. So dimension of P is equal to what then? T raised to -2 and T raised to 1 are cut. It is T raised to -1. You get it as ml T raised to -1. What is this? This is mass. Lt raised to -1 is velocity. Mass into velocity is momentum, linear momentum. It is called linear momentum. You have to write a knot there. Write a knot there. Last class I wrote many quantities having same dimensions. You have to add one more to that. Look at this. Write this. Sixth one. We wrote 5 if I'm correct. Sixth one is linear momentum. Linear momentum and impulse. You will learn impulse in fourth chapter. Impulse. IEMPULSE. Impulse. Impulse is actually force into time. Force into time. You'll learn that in fourth chapter, Newton's laws of motion. Okay. Repeating this part, you know what is this? What is this P now? P is mass into velocity. Mass into velocity is called momentum, linear momentum, linear momentum. We wrote different things in the last class. Do you remember? Do you remember the things that we wrote in the last class? Identical pace, spring constant, surface tension, Young's modulus, bulk modulus, rigidity modulus, stress, pressure. Do you remember? We wrote a lot of them. Then work, torque, energy, and then angular momentum and Planck's constant. And you have to add this to that. Linear momentum and impulse. That is another pair having same dimensions. Linear momentum and impulse. Linear momentum. This is asked in school examinations also. Linear momentum and impulse. Impulse is what? Nothing but force into time. Don't worry much about it. Okay. Hope you understood this. Is that clear? Everyone? Okay, so let's move to the next question now. So this is actually impulse. Answer is linear momentum. You will find either linear momentum or impulse in the options. Yes, option D is linear momentum. Yes. Let us look at question number 2 now. If S is equal to A plus BT plus CT square, A plus BT plus CT square, S is measured in meter and T is in seconds, the unit of C is. Let us do that. Yes. Easy question. All previous questions. A plus BT plus CT square. I've taken only previous questions. I've been given another equation now, A plus BT plus CT square. Find the dimensions of unit of C. How do you find unit of C? There is a plus sign here. So dimension of this should be same as dimension of this. Correct. Am I correct or not? Yes. See, I need to find the dimensions of C. I have to make use of what? Principle of homogeneity. If you see the plus sign, to the right of it is CT square, to the left of it is BT. They must be having identical dimensions. But, you know, see the plus sign. What is to the right of it? BT. What is to the left of it? A. They must be having same dimension. And there is an equality sign. To the left and right, same dimension. So these two dimensions are same. These two dimensions are same. Similar way, these two dimensions are same. So I could say these two dimensions are same then. Am I correct? Am I correct? Look at that. This is plus sign. To the right of it is CT square. To the left of it is BT. They have same dimension. Then this is plus sign. To the right of it is BT. To the left is A. Same dimension. Then equality. To the right it is A. To the left it is S. Same dimension. So these two have same dimension. So these two have same dimension. These two have same dimension. Then these two should have same dimension. So let us find it out. Dimension of S is equal to dimension of C into dimension of T square. I need to find that of C only. It is ES dimension divided by T square dimension. Okay, so dimension of C is equal to S is what? S is a distance. Distance is L. L T square. L by T square. So dimension of C will be L T raised to minus 2. What have they given? L T raised to minus 2. Is that there in the options? Oh, they are asking the units, right? Asking the unit. So unit means what? Length is measured in meter, time is measured in seconds. So meter raised to minus meter second raised to minus 2. Meter second raised to minus 2. Answer is option D. Yes. Yeah, we apply A equal to B, B equal to C. So A equal to C. That is it. That's it, Veda. Right. So answer is here is option D. Option D. Did you understand? Question number 3. A sphere A is moving with a velocity V under streamline condition. These are terms you haven't heard, but don't worry. These are learned later on in different chapters. Forget about all those things. Only focus on the equation alone. A sphere of radius A. So you know that radius is A. Question number 3. A sphere of radius A. So radius is A, moving with velocity V under streamline conditions in a viscous fluid. Those are terms you haven't heard of. Forget about it. Retarding force is given by, just see this, F is equal to KAV. KAV, where K is a constant. F is equal to KAV, where K is a constant. What are they asking? Dimensions of K. How do you find? Dimension of K is equal to dimension of force divided by A comes here, V comes here. So dimension of A into dimension of V. Okay, so let us put the dimension of K now. K is what? Force is mLt raised to minus 2 divided by acceleration is Lt raised to minus 2. Velocity is Lt raised to minus 1. T raised to minus 2, T raised to minus 2. So the answer is M. L goes to numerator, L raised to minus 1. Then T raised to minus 1 goes to numerator, is T raised to 1. ML raised to minus 1. ML raised to minus 1, T raised to 1. Did I miss something? F divided by... Oh, A is actually radius. I made a mistake. Sorry. A is not acceleration. They say that A is radius. Radius means it is L. So L and L are cut. T raised to minus 2, T raised to minus 1. It is T raised to minus 1. This is actually coefficient of viscosity. If you remember from last class. Do you remember this? This is called coefficient of viscosity. Do you remember? I'm asking the whole class. You didn't understand. I'm repeating. What is the question given here? They have given that force is equal to KAV. Oh, okay. Forget about the rest of the question. You just focus on the equation only. F is equal to KAV. F is equal to KAV. And V is what? I need to find the dimension of K. I'll keep it on one side. K is equal to force divided by A comes here, V comes here. Force by AV. Viscosity means the frictional force in liquid. Viscous force. There is a particular force in a liquid that actually resists the flow. If a liquid tends to flow, the flow is being opposed within it. Okay, that is because of viscous force. We will learn more in later on in another chapter. Okay, viscous force is something. For example, I'll just give you an example. You take a plate like this, inclined plate, put 1 drop of water, 1 drop of honey. Which will reach the ground first? Water. Yes. You take a plate and put 1 drop of water, 1 drop of honey. Which will reach the ground first? Water, right? Well, that is because water is less viscous. Honey is more viscous. It's actually viscous. If you take it in hand and feel it, you will understand. It is highly viscous. Tar, bitumen, that is more viscous, right? It's difficult to flow. If something is more difficult to flow, it is said to be viscous. Did you understand that now? But forget about it, you won't need it. It's actually, they are talking about viscous force here. This is a viscous force. Viscous force is yet another force anyway. It's actually a force. Viscous force is given by K into A into V. They have specifically mentioned that A is radius, V is velocity, F is force. What I need is K. I'll keep it on right side. A and V go to the left side. F by AV. What is force? mLt raised to minus 2. What is A? Not acceleration. I made a mistake. A is given as radius in the question. So I put L here. Velocity is what? Velocity is Lt raised to minus 1. L and L are cut, T raised to minus 1, T raised to minus 1 cut, you get T raised to minus 1. This L goes to numerator, ML raised to minus 1, T raised to minus 1. This is actually the dimension of viscosity, coefficient of viscosity. We wrote this in the last class. Dimension of coefficient of viscosity. This is very important for school examinations also. Dimension of coefficient. And in entrance examination, this has been asked more than 10 times. Dimension of coefficient of viscosity is ML raised to minus 1, T raised to minus 1. So, which is the correct one? Okay, you don't have to write that. The options, the dimensions are directly given. ML raised to minus 1, T raised to minus 1. Option B is correct. Did you understand that now? So, question number 4 we did. Question number 4 answer is option ML raised to minus 1, T raised to minus 1. Option A is correct. Oh, sorry. Question number 3, option B is correct. Question number 4, the force on a sphere of radius A moving in a medium with velocity is given by, same question. F is equal to, question number 4 is same as question number 3. In question number 4, they have given it this way, 6 pi AV. Right. In question number 3, it was given like KAV. That is because this 6 pi eta was called K. They took K in place of 6 pi eta. That is why question number 3 was KAV. Equation was KAV. But here 6 pi eta AV. Dimensions of eta are. Dimensions of eta we have found out. We don't have to do that again. It is ML raised to minus 1, T raised to minus 1. Okay. Read question number 4 again. That's a repeated question. Question number 4. Question number 4 is similar to question number 3. In question number 3, they write force as K, A, V. And when it comes to question number 4, they write it as 6 pi eta AV. Look at that. V, A. Then in place of K, you got 6 pi eta. They have called the 6 pi eta together as K. That's it. So anyway, they are asking you to find what? The dimensions of eta. Dimensions of eta. Eta is coefficient of viscosity. We have just done now. It is ML raised to minus 1, T raised to minus 1. Answer is option A. Did you understand? All the previous examination questions, either JEE questions or NEET questions. I've taken only such questions. Okay. So question number 5, 6, 7. Then we'll take a short break. Question number 5. Read question number 5. If E, M, J, G denote mass, angular momentum, and gravitational constant respectively, then EJ square by M raised to 5 G square has the dimensions of. Okay, so EJ square by, what have they given? EJ square by M raised to 5 into G square. So I have to check the dimensions of what? Read question number 5 again a repeated question. If energy E, mass M, angular momentum J, and then gravitational constant G represent the dimensions of energy, mass, angular momentum, and gravitational constant, then EJ square by M raised to 5 G square has the dimensions of. So you have to put everything, that's it. I'll tell you. Now, I'll tell you angular momentum. I wrote angular momentum in the last class, but that was written as L. I don't know why they have used J for it, but anyway, it's up to you. It's up to the one who sets the paper. You can use whichever letter you want. Anyway, angular momentum, usually J is used to represent impulse. Angular momentum dimensions, if you check, you will see this from last class notes. ML square T raised to minus 1. Angular momentum. I'm giving it for the moment. Dimensions of angular momentum, but never ever learn this by heart. Okay. You will automatically learn these things. Don't worry. ML square T raised to minus 1 is angular momentum. You don't have to learn these things by heart. Then gravitational constant we did in class. I told you this has been asked 32 times in entrance examination so far. M raised to minus 1 L cube T raised to minus 2. Those are the dimensions of angular momentum and gravitational constant. So let us put them here. E is dimension, energy is dimension. Tell me. Energy is dimension ML square T raised to minus 2 into ML square T raised to minus 2 into J square M L square T raised to minus 1 square divided by, so I have just substituted for E and J. Then what will remain now? E and J have already gone, then m raised to 5. Mass is m itself, so m raised to 5 into m raised to 5 into G square, capital G square. What is capital G? M raised to minus 1 L cube T raised to minus 2 square. So let us put the dimensions. Let us simplify this. What are we going to get now? This is m L square T raised to minus 2 into m square there, L square square, L raised to 4. L square, the whole square is L raised to 4. L raised to 4. Then T raised to minus 1 square, that is T raised to minus 2 divided by m raised to 5 into m raised to minus 1 square, m raised to minus 2, L cube square, L raised to 6, then L raised to 6, then T raised to minus 2 square, T raised to minus 4. Let us simplify the m's now. Let us cancel the m's now. Tell me how many m's on numerator? M square, m raised, m square, then m, that is m cube, right? M cube. So on numerator, m square and m cube. And then L square, L raised to 4, L raised to 6. T raised to minus 2, T raised to minus 2, T raised to minus 4 divided by, here it is m raised to 5 and m raised to minus 2. Look at that, m raised to 5 and m raised to minus 2. M raised to 3, then L raised to 6, then T raised to minus 4. M raised to 3, M raised to 3, L raised to 6, L raised to 6, T raised to 4, T raised to 4. All are cut. So m raised to 0, L raised to 0, T raised to 0 will be the answer. Is that given in the options? M raised to 0, L raised to 0, T raised to 0. Tell me, is that mass? No. Yes, that's right, Sahid. M raised to 0, L raised to 0, T raised to 0. That means there is no dimension, no dimension. So option A can't match because length has L. Option B is mass. Option C is time. Option D is angle. So this is having the dimensions of what? Angle is a dimensionless quantity. Angles do not have dimensions. Angles never have dimensions, okay? So what you got is, look at that, you just got an equation here, Ej square by m raised to 5 into g square. You just put energy here, then angular momentum here, then mass here, then gravitational constant here. Then you simplify this. In the end, you're getting m raised to 0, L raised to 0, T raised to 0, which means it is dimensionless. Okay, final answer is dimensionless, no dimension. 0m, 0L, 0T. So it can't be mass, it can't be length, it can't be time, because mass is m, length is L, time is T. It is neither of them, any of them, right? It's not any of them. And then only thing that is matching is angle. Angles do not have dimension. Angles dimension is m raised to 0, L raised to 0, T raised to 0. Did you understand that? Let us move to sixth question now. Sixth question. Read the sixth question, please. What is there in sixth question? Which of the following quantities has same dimensions as gravitational constant? Which of the following quantities has same dimensions as gravitational constants? You have to use trial and error method here. You have to do one by one. First is velocity square. Option A, let us check. Velocity square. Write down, let us do it together. Velocity square by mass per unit length. Mass per unit length. Okay, so let us do this and see if it is correct. Let us do one by one. What is the question? Which of the following quantities has the same dimensions as gravitational constant? You've been given 4 options. You have to check each and every one. Understood? 4 cases. Okay, so let us do one by one. First is velocity square by mass per unit length. What is velocity? LT raised to minus 1 square divided by, what is mass per unit length? Mass per unit length. Mass per unit length is m by L, ml raised to minus 1. From the name itself, it is clear. Mass per length means mass by length. Mass per unit length. Am I correct? Mass per unit length is m by L, that is m by capital letter L. ml raised to minus 1. So let us put it ml raised to minus 1. Okay. Then what? That is, let us check L square. Then what? T raised to minus 1 square. it is t raised to minus 2 by m L raised to minus 1. Let us simplify. M goes to numerator to become m raised to minus 1. Then L raised to minus 1, when it goes to numerator, it is L raised to plus 1. With L square, it is L cube. Then t raised to minus 2. Yes, spot on. Right. We have just hit jackpot. So this is same as what? These are same as dimensions of G. I don't have to check others now. Option A is correct. Look at this. What are we asked to find? We have to check which of the following options, which of the options given has dimension same as that of gravitational constants. So you have to take one by one. First is velocity square by mass per unit length. What is velocity? Velocity is L t raised to minus 1 the whole square. Velocity square divided by mass per length. What is mass per unit length? M by L. Mass is capital M, length is capital L. So length goes numerator, it is ml raised to minus 1. I put it straight away to this ml raised to minus 1. Then this is squared, L square, t raised to minus 1 square, t raised to minus 2. M goes to numerator, m raised to minus 1. L square, L goes numerator, L raised to plus 1. Already there is an L square and L cube, then t raised to minus 2. M raised to minus 1, L cube, t raised to minus 2. If you remember, these are the dimensions of gravitational constant. So answer is option A. Now you don't have to check, but if this fails, you have to check other options also one by one. Did you understand? So let us look at question number 7. If rho, that is Greek letter rho. Do not worry about the equations. They are all given now. So why worry about it? Why worry about them? Rho means density of Earth. R is radius, G is acceleration due to gravity, and G is gravitational constant on the base of dimensional consistency. The correct expression is. So you have to find which expression is correct. You have to find which expression is correct on the base of dimensional consistency. How do you check? This is how you check for dimensional correctness. You check one by one, everything one by one. Let us hope that we hit the right answer on the first go itself. Let us check option A. Option A. I'm going to check left side. Left side is what? Dimension of rho. Rho is density. Density, if you remember, is mass by volume. So it is m by L cube. It is ml raised to minus 3. Right. So first is what? First is dimension of density. Left side I'm checking now. Left side, dimension of density. Density is mass by volume. Mass is capital letter M. Volume is length into breadth into height. Volume is L cube. L cube is going to numerator, ml raised to minus 3. So left side is m L raised to minus 3. You have to check RHS now. For dimensional consistency, you have to check both sides, right? Both sides should have same dimension. Let us see 3g. So let us see 3g divided by 4 pi rg. 3g by 4 pi rg. Okay. So let us put the dimensions. What are the dimensions of 3? Nothing. 3 is a constant, no dimension. G's dimension, m raised to minus 1, L cube, t raised to minus 2 divided by 4 does not have dimension. 3 doesn't have dimension. It's a number. 4 doesn't have dimension for the same reason. Pi no dimension. This is radius. Radius is L. G is L t raised to minus 2. Let us check. L t raised to minus 2, t raised to minus 2 get cut. This is m raised to minus 1. L and L are cut with L square. So it is L. That is not correct. So option A is not correct. I'm trying my luck with option C now. I'm skipping B. I'm just checking with option C now. Option C. Okay. LHS is not to be checked because it is all wrong. RHS I have to check. RHS. Option C. I'm not checking option C. I'm trying my luck. I'm just jumping B. I'm trying my luck with C now. Okay. So let us see if option C works. RHS. Tell me what? RHS. Dimension of 3g over 3g divided by 4 pi r capital G. So what are the dimensions of 3? 3 no dimension, 4 no dimension, pi no dimension. G's dimension LT raised to minus 2 divided by radius is L. G is m raised to minus 1 L cube t raised to minus 2. L and L are cut. T raised to minus 2, t raised to minus 2 cut. So this goes to numerator. M raised to minus 1. Going to numerator it is m raised to 1. L cube going to numerator, upon going to numerator is L raised to minus 3. Yes, that is density. So option C is correct. Did you understand? And this is again based on one of the applications of dimension analysis. You are checking the correctness of the equation. Okay. So if the equation is to be dimensionally correct, both sides should have same dimensions. So check left side, check right side, check whether they are equal. Dimensions are equal. You have to check option A first. If it doesn't work out, or go for option B. Then if that also fails, go for option C. Likewise. Understood? It has to be done by trial and error method. Did you understand? Right. Question number 8. Question number 8. Read question. Question number 8. A certain body of mass m moves under the action of a conservation force with the potential energy given by kx divided by x square plus a square. Kx divided by x square plus a square. This is the potential energy, where x is the displacement and a is amplitude, whatever it is. The units of kr. Read it again. Read it again. A certain body of mass. You have a certain body. It has a mass m. Moves under the action of whatever it is. Don't worry much about it. Potential energy is given by. So this is potential energy, not velocity. They say that this is potential energy. Okay, potential energy is given by V is equal to kx over x square plus a square, where x is displacement and a is amplitude. Unit of xr, unit of kr, units of kr. How do we find this? Units of k, I'll tell you. Look at this. Do you see any equality sign? Do you see any equality sign or plus sign or minus sign? Yes, we have an equality sign. Let us check it out. So dimension of V must be same as dimension of k divided by dimension of x square plus a square. Look at that. Look at that. Look at that. See this. So what am I doing now? I am being asked to find the dimensions of k. Oh, kx, dimension of k into dimension of x. So I'm just applying dimensions everywhere. What is the question? They say that potential energy, this is potential energy, expression for potential energy. Potential energy is given by kx divided by x square plus a square. X is displacement. V is potential energy. I apply dimensions to all. Dimension of V is equal to dimension of k into dimension of x divided by dimension of x square plus a square. Then what I need is k. I'll keep it on right side. Take all others left hand side. Tell me, this is going to the left. Dimension of V into this box comes here. X square plus a square divided by that x will come to denominator. X will come to denominator. Okay. So this is how we get it. Dimension of, I told you what I need is dimension of k alone. I'll keep this dimension of k on the right side, and then x square plus a square comes to left side. X square plus a square comes to left side. Dimension of V into x square plus a square comes here, divided by dimension of x. So I can put the dimension of k here. This is dimension of k. So what are dimensions of k now? Let us put one by one. This is not velocity. Remember, this is energy, potential energy. They had actually given that, no? Potential energy is what? Energy is ml square t raised to minus 2 into. What is x square? X square is L square. So a square is also L square, because mangoes can be added with mangoes only. Apples can be added with apples, right? Oranges can be added with oranges. So if x is mango, a is also mango. Understood? So dimension, see, you have a plus sign here. Both sides should have same dimension, x square and a square. Am I correct? Oh, tell me, what is the sum of 7 seconds and 3 meters? What is the sum of these two? Can someone tell me? Can you hear me? Can you hear me? This can't be done. 7 seconds and 3 meters can't be done. And it can't be added. So you can add them only if both are seconds or both are meters, right? Similar way, if this is L square, x square is L square. This is also L square. L square plus L square, 2L square. Never write that. Dimensions can never be added. You just write only one time for them. This is L square, this is L square. So as a representative of both, you write L square only one time. There is no meaning if you add or subtract dimensions. Even if it is minus, you won't take L square minus L square 0. You have to write only one representative L. Understood? L square divided by X is what? X is L. So let us cut L and L. What do we get now? M, L square and L. L cube T raised to minus 2. These are the dimensions of K. One more time. So they have given potential energy. This is not velocity, remember. This is potential energy. Is given by Kx divided by x square plus a square. They are asking you to find the dimensions of K. So I apply dimensions to all the terms. Dimension of potential energy is equal to dimension of K into dimension of x divided by dimension of x square plus a square. I don't mind what a square is. Anyway, I cross multiply, I get dimension of potential energy into dimension of x square plus a square by dimension of x equal to dimension of K. What are dimensions of potential energy? Energy ml square t raised to minus 2. What are dimensions of x square plus a square? X is distance, displacement. So it is L square. This is L square. L square plus L square, 2L square. But you have to write only one L square. That is what I've done, L square. Dimensions can never be added. This is L square, this is L square. Right. Divided by X is L. So L and L are cut. L and L square, L cube. That makes it ml cube t raised to minus 2. Is it there in the options? Oh, they are asking what this is. ml cube t raised to minus 2. ml cube t raised to minus 2. So let us check. Anyway, it is not watt. It is not watt. Amplitude is same as distance. Yes. Amplitude is same as distance. Maximum value of distance is called amplitude. Okay. So they are asking you to check this out. The options, no? There are different options. Anyway, I'm sure about one thing. This is not option B. Option B is not correct because option B is Joule, which is energy. Energy. Option A, it is watt. Watt is power. Power dimension, we did this in last class. Power dimension is ml square t raised to minus 3, power dimension. Then option C, let us check option C, Joule meter. Joule meter, let us check. 1 second, please. Thank you. I'm sorry. Joule meter, let us check. Joule meter, let us check. What is Joule meter? Joule is energy, ml square t raised to minus 2. Meter is L, length. So that makes it m, L square and L cube t raised to minus 2. So that is ml cube t raised to minus 2. Repeating, Joule into meter. Joule is what? I'm trying Joule. I'm trying option C. Option A is wrong because power dimension is ml square t raised to minus 3. Check your notes. It is there. Then option B is Joule. Joule is not possible because Joule is energy, which is ml square t raised to minus 2. Then option C, I'm checking option C now. Option C is Joule meter. Joule is energy, ml square t raised to minus 2. Meter is length, L. L and L square, L cube, ml cube t raised to minus 2. That exactly matches with our answer here. So answer is option C. Did you understand? Question number 9 is an important question that got repeated in entrance examinations. If unit of length and force be increased to 4 times, then the unit of energy is. Read it again, it's a little complex. Not complex anyway. If unit of length and force be increased to 4 times. Unit of length and force be increased to 4 times. So unit of length is increased to 4 times. Unit of force is increased to 4 times. Length and force are increased to 4 times. Okay. Okay. Length and force are increased to 4 times. Then unit of energy is. Tell me, look at this. Energy is what? Energy is actually same as, dimension of energy is same as dimension of work, which is same as dimension of force into dimension of length. Work is force into distance, right? Force into distance. And they say that this is energy. So I'm writing energy first. Energy is what? Dimensions of energy are dimensions of force into dimensions of L. Okay. And they say that the new case, E dash. What are you doing here? Force is made 4 times. So it is 4F. And length is made 4 times, 4L. So 4 into 4 is what? 16. Dimension of F into dimension of L. What is this? that is old energy. So energy, unit of energy becomes 16 times. 16 times. I'm repeating. Actually, this should be done by another method. This is a short trick you can use. Okay, I'm just telling you the short trick now because other one is a little complex. I'm telling you one more time. Read the question carefully one more time. Okay, it's a very, very important question. If unit of length and force be increased to 4 times, length is increased to 4 times, unit of length is increased to 4 times. Unit of length now is meter, that is made 4 meters. Unit of force is increased to 4 times. That means unit of force now is Newton, it is made 4 Newton. So both units of both force and length are increased to 4 times unit of energy. So which all things are involved here? In the question, which all things are mentioned here? Energy is mentioned, force is mentioned, length is mentioned. Did you notice that? In the question, they have mentioned energy, force, and length. So you must relate those terms. So energy can be written as force. Energy can be written as what? Energy same as work. Work energy theorem. Energy is same as work. When you do some work on something, that is converted to its energy. Correct. When you push a car, you're doing a work. The car moves because it gets energy. So work is same as energy. Energy is same as work. That is force into length. So dimension of energy is equal to dimension of force into dimension of length, or unit of energy is equal to unit of force into unit of length. They say that both the units of force and length are quadrupled 4 times. So force becomes 4 times, length becomes 4 times. Force becomes 4F, length becomes 4L. 4 into 4 is 16, 16, F into L, F into L. F into L is old energy. So 16 times old energy is new energy. So the unit of energy becomes what? Answer is 16 times, increased to 16 times, option C. Mark the homework. So now take down some homeworks. I'll tell you which all questions are homeworks here. Try those questions at home. These are multiple times asked questions. Okay. Multiple times asked questions. So question number 10 is homework, 11 homework, 12 homework, 13, 14. 5 homeworks are there, 11 to 14. 11 to 14. Then till 17 it is done. Okay. Question number 11, homework for you. Question number 12, question number 13, question number 14. 11, 12, sorry, 10. 10, 11, 12, 13, 14. Next class you have to submit. Okay, I'll tell you how to submit. 10 till 14 are homeworks for you. Okay. Write an extra question now. The position of a particle, the position of a particle is given by the position of a particle is given by I've written on the board. The position of a particle is given by x is equal to V0 by alpha into 1 minus e raised to minus alpha t. The position of a particle is given by V0 by alpha into 1 minus e raised to minus alpha t. E raised to, E means x. Right, e raised to minus alpha t, 1 minus e raised to minus alpha t, where V0 is a constant, I'm not giving the options. It's a NEET question. It's a previous NEET examination question. So you have to just write that. I'm not giving the options. I'm just asking you to find the answer. The position of a particle is given by x is equal to V0 by alpha into 1 minus e raised to minus alpha t, where V0 is a constant. Find the dimensions of V0 and alpha. Find the dimensions of V0 and alpha. Find the dimensions of V0 and alpha. Tell me when you finished writing the question. The position of a particle is given by x is equal to V0 by alpha into 1 minus e raised to minus alpha t. All right. Find the dimensions of V0 and alpha. Shall we start doing this? Hope you finish this. Tell me please. Okay, how is this done now? I'll tell you. Look at this. First of all, this is a dimensionless thing. This is a dimension. Exponential function is a dimensionless thing. Exponential function. Exponential functions are like logarithmic functions. They are dimension like angles. E raised to something does not have a dimension. If this is not have any dimension, I would say that dimension of alpha must be equal to dimension of 1 by time. Do you agree with that? Because then only they can cut with each other. Am I correct? Oh, I'll tell you. I'll do by another method. Look at that. What do I want? I know that exponential function, exponential. That is how it is called, exponential. That means e raised to exponential function. Exponential function is dimensionless. No dimension for e raised to. Exponential function is dimensionless. E raised to something that does not have a unit. So this does not have a unit, which means what? This dimension alpha t, dimensions of alpha t will be what? M raised to 0, L raised to 0, T raised to 0. Am I correct? You didn't understand. See, this exponential function is always dimensionless. Whenever you see this, you can take the dimension of the power as, that will be a number. That will be a number without a unit. This will be a number without a unit. Forget about the sign also. You don't have to take the sign also. So dimension of alpha t must be what? M raised to 0, L raised to 0, T raised to 0. No dimension. So dimension of alpha will be what then? M raised to 0, L raised to 0, T raised to 0 divided by, T comes to denominator. That is divided by T. What do we get then? The answer is T raised to minus 1. Did you understand this part? Anyway, just know this. Exponential function, the exponential function as such is dimensionless, or even the power of exponential function is dimensionless. The power alpha t has no dimension. Alpha t is m raised to 0, L raised to 0, T raised to 0. What I need is alpha. I'll keep it here. T goes to denominator. So T is capital T. Then these are 1. So take it numerator, T raised to minus 1. Or think of it this way. This is minus sign. On the left side, it is a number. Without dimension. So on the right side of it also is dimensionless. So that actually gives you an idea about the dimension of alpha. Dimension of alpha is T raised to minus 1. Okay, so let us think about the other thing now. Tell me, dimension of alpha is this. So dimension of alpha I found out, it is T raised to minus 1. Let us look at the second one. This won't be asked in school boards. Okay, advanced level question. And tell me, I see an equality sign. What is to the left of x? Left of equality sign, dimension of x. What is to the right of it? Dimension of V0 by dimension of alpha. Why don't I write this? Because that is already dimensionless. This bracket itself is dimensionless. So I can just get rid of it. So I can cross multiply now. Dimension of V0 will be what? Dimension of x into dimension of alpha. X is L. Alpha is T raised to minus 1. So the final answer is LT raised to minus 1. Repeating one more time. I see equality symbol here, equality symbol. So all of a sudden, one thing comes to my mind. What is that? Principle of homogeneity. When I have an equality sign or a plus sign or a minus sign, look to either side. Look at that. This is an equality sign. What is to the left of it? It is x. What is to the right of it? V0 by alpha into a bracket. But forget about bracket, because bracket is a dimensionless thing. So when you talk about dimensions, you can get rid of it. Correct? Correct. You don't have to mind this because that's already dimensionless. So dimension of x should be same as dimension of V0 by alpha. Immediate left and immediate right. Dimension of x is equal to dimension of V0 by dimension of alpha. Cross multiply. Dimension of V0 would be what then? Dimension of x into dimension of alpha. X is what? L. Alpha is what? T raised to minus 1. So x alpha is L T raised to minus 1. So dimensions of alpha are what? T raised to minus 1. Dimensions of x V0 are what? L T raised to minus 1. So that's all for the day.